this is an example for the data analysis of consolidated drain, CD test, and sometimes CID, also known as CID, consolidated isotropically drained triaxial test. So a drain triaxial test was carried out on 3 samples. So there are 3 samples here, given the data from the test as shown below. So as you can see here, that the data recorded in this triaxial test are the cell pressure, which is the sigma 3, and also the deviated stress at failure. Alright. So the deviated stress at failure, we will increase the deviated stress at the last stage of the triaxial test, at the shearing stage, until the sample fail. Alright, and we apply the sigma 3, the cell pressure, during the consolidation stage. Alright, so now what we need to do is to plot the Mohr circle for all 3 specimens here, and we need to draw the failure envelope and determine the shear strength parameter of soil. Okay, now as you can see here, in order to plot the Mohr circle, okay, in order to plot the Mohr circle, okay, in order to plot the Mohr circle, we need to have the sigma 3 and sigma 1. So the data recorded here is sigma 3. Okay, so we have the sigma 3 and the sigma d. So we don't have the sigma 1, but we can get the sigma 1. Knowing that the sigma d is actually the diameter of the Mohr circle. Alright, so the sigma d is the diameter of the Mohr circle. So you can get the sigma 1 by adding the sigma 3 with the sigma d. So you will have the sigma 1. As you can see here, when 100 plus with 220, you will have 320 for the sigma 1. Okay, now, you can also see here that the sigma 3 equivalent to sigma 3 prime and sigma 1 is equivalent to sigma 1 prime. So this is happened due to the consolidated drain test will give you an effective stress analysis. Okay, when we are dealing with the effective stress analysis, you will have this kind of symbol, which is the prime symbol. Alright, so consolidated drain will give you an effective stress analysis because the pore water pressure U at the end of the test will equal to 0. Right, in the CD test, you will have the U will equal to 0. Why? Because during the consolidation and also during the drain or during the shearing stage. Okay. So we have the shearing stage. In the shearing stage, there are 2 conditions, whether it drain condition or it's undrained condition. Since now we are focused on the drain condition, so that's why we have D here. So in order to allow water to drain out, so we need to open the drainage valve. So when we open the drainage valve, means that we'll allow water to flowing out. When you add the sigma D is the deviated stress, is a loading to the triaxial test sample until the sample fail. At the same time, so the water will flowing out until U will equal to 0. And there is no excess pore water pressure at the end of the experiment. So that's why you will have the U equal to 0. So knowing that from this equation, okay, the effective stress prime will equivalent to total stress, which is the sigma here minus with U. So now when U equal to 0, so what you have is the sigma prime equivalent with the sigma. So that's why we have sigma 1 prime equivalent to sigma 1 and sigma 3 prime equivalent to sigma 3. So by right, for the consolidation drain test, so this is sigma 3 prime, sigma 1 prime. So this scale of x axis also in prime and y also tau prime. So now let's plot the data on the graph paper. So prepare your graph paper. Make sure you have the x-axis here and y-axis here. And make sure that your scale for x and y must be similar. Similar means if you have 100 here, so same goes to Y, you also need to have 100 with the same gap. With the same gap, Y and X. Alright? Okay, and I would suggest to you to landscape or to make your graph paper in horizontal, so to ensure that you can fit all the Mohr circle, because sometimes, most of the time, the sigma 1 can up to more than 1000. In this case, you can see here that it's 954. Alright, so use the suitable scale that you can plot all the Mohr circle clearly and neatly on the graph paper. Okay, now we need to plot, we need to draw the Mohr circle. So to draw the Mohr circle, it is a circle. It is a circle. So normally when we draw the circle, we must know where is the center of the circle, and we must know the radius of the circle. We must know the radius of the circle. So in this case, we know that the circle will start at 100 here as a sigma 3 prime, and the circle will end at 320 here, sigma 1 prime. But where to start? Okay, so we have the 100 here. We have the 100 here, that the circle will start here, and the circle will end somewhere here. But how to start to draw? We need to know the center of the circle. So what we can do here is that we know that the sigma d is the diameter of the circle. So in this case, for example, we have 220. Sigma d, which is the diameter, is 220. So to get the radius, we can divide it by 2. So you will have the radius is 110. Okay, now you cannot simply take the 110 as a center of circle. And obviously, this can't be center of the circle, because the circle will start at 100 and end at 320. So this is not the center of the circle. Okay, to become the center of the circle, you need to plus 110 with the beginning of the circle, which is 100. So you will have 210. So this is the center of the circle, somewhere here. So by knowing the center of the circle, so you know the radius. Okay, you know the radius of the circle. So using your compasses, the jangka lukis, the set of the jangka lukis, alright, you tandakan here, and then buat bukaan ikut size R kat sini, the size of the radius, and then you can simply draw the Mohr circle. Okay, so since we have 3 samples, so you need to draw 3 Mohr circle on the graph paper, on the same graph paper. Okay, now we settle to plot all the Mohr circle. Now we need to draw the failure envelope. The failure envelope is tangent to the Mohr circle. Alright, so this is the failure envelope. Okay, that is the failure envelope. The failure envelope, okay, the failure envelope line must intercept at y-axis. The failure envelope line must intercept at y-axis minimum at 0. Okay, we cannot go negative, and the failure envelope cannot go inside the Mohr circle. This is wrong. It must minimum at 0. Okay, so in this case, it intercept at 0. It depends on different cases. Somehow that the Mohr circle will give you more than 0, the intersection between the failure line with the y-axis here, the shear stress here. Alright, so this intersection will give you the cohesion value, the C value. So in this case, you will have the C prime. Alright, so because why prime? Because this is an effective shear strength analysis. So the C will have the unit. Alright, so make sure you don't forget the unit of the C. Alright, because this is from the stress, so you will need the unit. Okay, now actually we have one of the effective shear strength here, which is this cohesion value, one of the shear strength parameter. Now the other parameter is the angle of friction here. This is another effective shear strength parameter. Again, we have prime here due to the effective shear strength analysis. So this is another one of the shear strength parameters. So we need to measure the angle of friction. So use your protector. Alright, and then measure your angle of friction. So this is the angle of friction. So now we have complete the effective shear strength parameter. So we have C prime and also phi prime, or angle of friction prime. Always remember, from the CD test, you will have this kind of shear strength parameter and effective stress analysis.